Hey y'all, I am going over Unit 10, pages 101 to 106, some homework help. I am going to try and clarify some of the misunderstandings that I've been overhearing. So starting with number 1, this is on page 101. It says, what is the y-intercept represented in the graph? So the y-intercept is where my line crosses the y-axis. So if I'm going straight down here, it's going to be where this line, whoops, I can't put the cap on that, that's the wrong cap, where this orange line and this purple line meet. So there's a meeting point there, and that will be my y-intercept. Going forward to number 2, it says, what is the rate of change for the data shown? Ironically, this is a proportional relationship, but when it's asking for rate of change, we always want to calculate the delta y over the delta x. So down here is delta y, and up here is delta x. Now, delta means change, and that's delta y over delta x, and we write them as a ratio. So from 6 to 18, I am adding 12, and from 1 to 3, I am adding 2. So I will put those in a ratio as 12 to 2, and then I would simplify and calculate that there. All right, number 3, it says Claire earns, the same pay for each day she works at her new job. She deposits a weekly paycheck into her savings account. So this says Claire's savings per the number of days that she works and then her balance. How much money did Claire have in her savings account before starting her new job? So before starting her new job, she worked 0 days. So 0 days of work. Write your answer in the space provided. So I like to expand my table. So over here, where I'm showing my work, I'm going to make a new table. Then I'm going to split it. This is number of work days. And this is savings balance. So they give me 5, 10, 15, and 20 days. And then I have $130. I have $250. I have $370. And I have $490 amounts there. So I need to find a pattern. What is the pattern from her balance, savings balance, and then what is the pattern for her days? So for every some number of days, I get some number of amount of money. So from here to here, I'm going to take 250 and I'm going to subtract 130, and then I'm going to get a number. Then I'll take 10 and I'll subtract 5. Obviously, we should know this off the top of our head. This is 5 days. So if I were to go backwards 5 days, so this is adding 5 days, this would be subtracting 5 days, I would be at 0 days. This is her start. This is her initial value. This is also her y-intercept. Okay, it's where it crosses that y-axis. So what amount of money did she start with over here? Remember, I'm going to add a certain amount of money over here. So if I'm adding something to 130 to get to 250, I'm going to need to subtract going backwards. So going backwards, subtract whatever amount you get here. Then that will be the start of her savings account. Number 4, it says, look at the graph. Oh, my graph doesn't show grid lines. Hold on. Let me see if I have a different copy. I don't think I do. Hold, please. Okay, really quickly, here's the visual that doesn't really show up very well on my paper. So I'm looking for 2 friendly points here to make my triangle. So I'm going to run 1 and jump 3. So there's a point right there. And then I'm going to run 7 and jump 7. And then I'll make my rise over run that way. So let me go back to my camera. All right, so there are those points. So I'm going to draw a triangle, and then I'm going to calculate my rise over run. This is my rise. This is my run. They both have a certain number of units. So this unit is right here between 2 and 4, and this unit is up here between 6 and 7. So how much do I rise and how much do I run? This is 1 and 7 as well. So that's going to be my ratio, and then that'll tell me how many miles per minute, because a rise is miles and a run is minutes, I'm going. Number 5, it says which description best represents the data. So this is a 0 and 22. This is my start. This is where I begin. It says 1 American dollar is equivalent to 23.5 Canadian dollars. Sure, 1 equals 23.5, but then realistically, would this make sense if I go to Canada with $0, they're just going to hand me 22 Canadian dollars? No, that's not possible. Here it says a baby measures 22 inches long at birth, and then the baby grows 1.5 inches each month for 3 months. Well, I need to see the difference here and here. This is plus 1 month. This is plus 1.5. Looks good to me. This is plus 1.5, and this is also plus 1. So this is 1.5 for every 1x. Then it says Jenny has $22 in her bank account, and she spends $150 every day. A spending of $150 means I'm subtracting here, and I'm not doing subtraction. And then it says a plant grows at a rate of 3 centimeters per month. Well, that doesn't even show relationship here, because then that would mean that my plant would have to start at 22 centimeters, and it doesn't explicitly say that. All right, let's go to page 102. 102 says, a supermarket advertises a new product by offering samples to customers. The table shows the number of samples distributed each hour. So a supermarket's got hours and samples. So if I go up 1 hour, then I'm going to go up a certain number of samples. So the difference between 114 and 76 is relative to the difference of 3 and 2. Remember, these are points, and I can make a slope from these. The point is 276 and 314. Whoops. So this is samples per hour. This is what they give me. I need to do the calculation. Number 2, it says create a true statement about the slope and y-intercept of the graph. I have a little bit darker grid lines here. Let me autofocus and see if it'll get a little clearer. Nope. But I'm going to take this point right here, and I'm going to take this friendly point here, and I'm going to rise and run. Oh, wait, did I do that on the other page? Yes, I did, but I also needed to make note that this is increasing. So it's going to be positive. Always need to double check and make sure if it's increasing or decreasing. Okay, so this one is going from the left to right. As I read this line, is going down. So this is going to be negative. And then I'm going to look, how many units do I rise? This is 2. And then I run 4. So I'm going to put my rise over run, but it's going to be negative something over something. These numbers are going to be it, and then you need to simplify or convert to decimal. Then it says the y-intercept. Where does it cross the orange line? So we need to look at where it crosses that orange line and go from there. All right, so I believe I left off on question number 3. Sorry, I had to take a pause there. And it says a mountain bike rider travels 10 miles on the state park bike trail. Say that 5 times fast. Excuse me. The graph describes the bike rider's movement along the trails. So again, I'm looking at this line and I'm trying to find friendly points. So boom, there's one at running 2 and jumping 25. So 2 and 25 is going to be on my paper. And then I'm going to keep running, and I found another point here at 4 and 50. So then going back to my paper, there was 4 and 50. So I'm going to make my triangle, my rise, and my run. So my rise is from here to here. So how many between 25 and 50? It's a difference of these two, and then a difference of these two. So this is the rise. How far do I rise from 25 to 50? And then this is the run. How far do I go from 2 to 4? So then it's going to be a rise over run. And then I'm going to simplify that ratio. Then at the bottom, it says the Lone Star Plumbing Company specializes in leak repairs. A service call fee and an hourly labor rate is charged for each repair. So a service call fee and an hourly labor rate is charged. After 1 hour of labor, they have paid $65. And then the next hour, they are paying $105. And then the next hour, they're paying $145. And the next, they're paying $185. So if I look here to find out the rate of change from my hourly rates, I feel like this one's easy and this one's easy. So I'm going to jot this down. I've got hours of labor and then total cost. I've got 1, 2, 3, 4. I am purposefully leaving this blank because in case I need the 0, I need to put it in there and take it into account. And this is 65, 105, 145, and 185. So now I'm going to find my rate of change. How is my cost changing in relation to my hours? So this is my delta y, because this is my y column, over my delta x. This is my x column. So how do I get from 65 to 105? That's 105 minus 65. And this is 2 minus 1. Obviously, this is 1. So this is going to be delta y over delta x. It's going to be a cost per hour. X is my hours, Y is my cost, and then I'll put them in a fraction. So whatever cost I get over here goes over the number of hours here, and then I need to go backwards because whatever I'm adding here, I need to go backwards to find out how much it is for 0 hours. So remember, this is the total for the repairs and the call. All right, so we're going to go to number 1 on page 105. It says, Jana sells boxes of cookies for a school fundraiser. Each hour, she records the number of boxes sold. Jana's cookie sales are represented by the graph. This is proportional. Obviously, after 0 hours, she sells 0 cookies. Here, if you run and jump, this is 1 and a certain number of cookies. This is 2 and a certain number of cookies. This is 3 and a certain number of cookies, and 4 and a certain number of cookies. So we want to know what this point is. You run 1 and then you jump some number, and that's going to be your cookies per hour because it is proportional. It's starting at 0, 0, the origin. All right, look forward to the next video coming up.